In this video, I would like to explain about measurement of pH using different methods. Measurement of pH using different methods. As we all know that pH is the negative logarithm of hydrogen ion concentration. pH is the negative logarithm of hydrogen ion concentration. So, in order to find out the pH of a solution, we can use different methods. They are indicator methods, metal-electrode methods, glass-electrode methods, semiconductor sensor methods. These are the methods used to detect the pH of a solution. First one is indicator methods, then metal-electrode methods, third one is glass-electrode methods, and fourth one is semiconductor sensor methods. Now we can discuss each one of these in detail. First one is measuring pH using an indicator. Measuring pH using an indicator. This basically includes two methods. The first one involves comparing a standard color. Comparing a standard color with a known pH or corresponding to a known pH. Comparing a standard color corresponding to a known pH with the color of an indicator solution. With the color of an indicator solution which is dipped in the test solution using a buffer solution. Here we have a standard solution with a known pH. So we are comparing pH of the test solution by immersing or dipping the indicator in the solution with the help of a buffer. The second methods involve preparing a pH test paper. pH test paper which is soaked in the indicator. pH test paper which is soaked in the indicator. Then immersing the paper in the test liquid. This indicator paper immersed in the test liquid and comparing its color with the standard color. So first prepare a pH test paper which is soaked in the indicator. Then this immerse in the test liquid and comparing its color with the standard. This method is simple but highly error prone. A high degree of accuracy cannot be expected by using this method. When we are using this method, different types of errors occurs. First one is error due to high salt concentration. Error due to high salt concentration in the test liquid. High salt concentration in the test liquid. Next one is error due to the temperature of the test liquid. Temperature of the test liquid. Third one is error due to organic substance in the test liquid. Organic substance in the test liquid. So, this method cannot measure the pH of high purity water. It cannot measure the pH of high purity water because the influence of the indicator itself too large. The influence of the indicator itself too large. Next one is Hydrogen-Electrode Method. In this method, a hydrogen electrode is made by adding platinum black. By adding platinum black. A platinum wire or platinum plate. First one, a hydrogen electrode is made by adding a platinum black to a platinum wire or platinum plate. And it is immersed in the test solution. It is immersed in the test solution and an electric charge is applied to the solution. So the solution is saturated with the hydrogen gas. Then the electrode potential between the platinum black electrode and silver chloride electrode. Silver chloride electrode. And this potential is inversely proportional to the pH of the solution. And this potential is inversely proportional to the pH of the solution. So first we want to make an electrode by using a platinum black to a platinum wire or platinum plate. Then it is immersed in the test solution and electric charge is applied to the solution. So the solution becomes saturated with the hydrogen gas. Then the electrode potential is measured between the platinum black electrode and the silver chloride electrode that we are using as standard electrode. And this potential is inversely proportional to the pH of the solution. And this is a standard method among the various methods for measuring the pH. This is a standard method. But this method is not used for daily use because of the effort and expense involved, with the inconvenience of handling hydrogen gas and great influence of highly oxidizing or reducing substances in the test solution. So this method is not appropriate for daily use. Next one is Quinhydron-Electrode Method. Quinhydron-Electrode Method. When quinhydron is added to a solution, it separates into hydroquinone. Hydroquinone and quinone. When quinhydron is added to a solution, it separates into hydroquinone and quinone because solubility of quinone depending on the pH value of the solution. And the pH can be determined from the voltage between platinum and reference electrode. Platinum electrode and reference electrode. This method is simple, but it is only used rarely because it does not work when oxidizing or reducing substances are involved. This does not work when oxidizing or reducing substances are involved. Similarly, it does not work when the test solution has a pH above 8 or 9. It does not work when the pH of a solution, test solution, has above 8 or 9. So in this solution, when quinhydron is added to a solution, so it separates into hydroquinone and quinone, and the pH is measured from the voltage between platinum and reference electrode. Next one is Antimony-Electrode Method. In this method, immersing the tip of a polished antimony rod into the test solution, and also immerse the reference electrode. Immerse the reference electrode and the measuring pH from the difference in the potential between them. First, dip the tip of the polished antimony rod into the test solution. Similarly, the reference electrode also dipped in the solution and measuring the pH from the difference in the potential between them. Once this method was widely used because of the easiness to handle, but now it's quite limited because the results vary depending on the degree of polish of the electrode and reproducibility is low. So now its use is limited. Next one is Glass-Electrode Method. Glass-Electrode Method. In this uses two electrodes. One is a glass electrode and the other one is a reference electrode. Reference electrode. So two electrodes are used in this, and determine the pH of the solution by measuring the voltage between them or potential between them. Most commonly used method for the measurement of the pH, because the potential quickly reaches the equilibrium. The potential quickly reaches the equilibrium and shows good reproducibility. Shows a good reproducibility. And because of the method, because the method can be used on various types of solutions. We can use this method on various types of solution with oxidizing or reducing substances having very little impact on the result. So the glass electrode is widely used, and not only in the industry but also in many other fields. Next one is semiconductor sensor method. Semiconductor sensor method. The semiconductor sensor or semiconductor pH sensor was developed in 1970. So it replaces the glass electrode with a semiconductor chip. Glass electrode with a semiconductor chip. And this sensor is known as sensitive field effect transistors. So also known as sensitive field effect transistor. And it allows the use of smaller amount of samples for measurement and makes it possible to perform measurement in very small spaces and on solid state surfaces. So that is, it uses smaller amount of sample for measurement and perform the measurement in very small spaces and on solid state surfaces. So this mainly used in applications in measurement in the field of biology and medicine. So it's mainly used in the fields of biology and medicine. Next one is pH imaging. pH imaging. This is a measurement method in which pH is determined at multiple points. pH is determined at multiple points and the results displayed as an image. As an image. The result displayed as an image. And it is used as a technology for visualizing pH distribution. Visualizing the pH distribution. These are all about measurement of pH using different methods. Thank you.